So, here we are, week 4, and we've formed the groups for about half of you. Those groups are going to be used for the purpose of working on your little projects and also for the little presentations that you guys are going to work up probably a couple a week for the rest of term until we run out of volunteers, or not so much volunteers, but run out of groups. And so I will produce a schedule of the various topics week by week that you will then research. They'll be kind of related to data analytics and also SAS, so that you can sort of merge the two together as part of developing your overall project. If you look in study materials, then you'll find the link here to the YouTube videos. Right above the various presentations and other interesting things. Did anybody look at Roberto Zaccari's presentation about big data and value for organizations? Perhaps everybody ought to have a look at it, because again, that's going to give you an amazing background as to what big data analytics is all about. Why we're so amazingly interested at the moment in this thing called big data. And he's making a point there. It's all about the impact we can make on the economy and potentially upon society. There are things we can do in relation to smart cities, to do with improving sustainability. We have a new institute down the Kettleston Road called ICE, which is an institute set up as part of, or alongside, the College of Engineering and Technology, about sustainability in engineering into the future, whether it's to do with better insulation of buildings, whether it's to do with the use of big data, Internet of Things, all of those smart sensors in houses and in cities to make traffic flow more easily, more smoothly, or whatever. There's an amazing, it is claimed that there's an amazing impact to be gained from all of this data, if we can find ways of analysing it. And one of the fun things is that SAS is one of the major tools that's used out there in the big wide world for doing all of this analysis. Yes, there are other products that are open source. There's also the IBM product set, Cognos and SPSS and SPSS Predictives. There's also a whole suite from Oracle. But SAS is one of the really, really big ones, and used by a very large number of very big organizations. And so they're doing a lot of work, a lot of organizations to do this sort of thing. So I really would very strongly recommend that you have a look at that, and I will set up probably tomorrow a little discussion board area where you can make your contribution, having looked at that and identified 2 things that you think are really important messages coming from Roberto's presentation. In fact, while we are here, let's go and add, we're on week 4, aren't we, here? Add me a thread. So there it is. Up there for you to each make one posting about what you felt was the two most important messages from Zakari's presentation. So that's to get you really looking at some of the most important stuff we've got. Really, really critical. A couple of weeks ago we looked at operations strategy. Last week you looked at this extract, transform and load. How do we get information into these systems that we're looking at, whether it's SAS or Cognos or R or anything else. That was a fundamental process that you're going to have to go through when you start looking for the big data sources that you're going to be loading into your little system. And so, from next week onwards, as I say, two groups of you are going to do two five-minute presentations about an interesting topic. And I'll name the sets of topics, and then you'll have to do a little bit of research. You'll probably want to look into some of the SAS manuals to find some of the interesting information that you're going to pass on to your colleagues, and we'll see how the whole thing develops. Because the reason for doing presentations at this stage in your career, right in your first year, second semester, yep. So you had a bit of skills stuff last term, most of you, and this term we're going to start on the communication game. Because out there, one of the greatest criticisms of British and many other nations' universities is that graduates come out of university unable to communicate. So we're going to give you practice in communicating so that you actually get over your jitters. And of course, your first presentation, you're going to be nervous. And yes, probably your first presentation, if it's scheduled for 5 minutes, it'll take 10 minutes. If it's scheduled for 10 minutes, it'll take 15, 20 minutes, because you haven't quite thought about some important questions like, what do I want to say compared to what do I need to say? And a few other little things like that, which we covered for many of you last semester. And so this first presentation is kind of just to get you over that little step. I've never, ever done a presentation before. I'm nervous. We're nervous. Okay, great, let's do it. See what happens. And we'll sit out in the back there, and we will provide helpful, positive ideas. We will not say that was rubbish. We will suggest it a different way around that says, do you think that if you had done this, it might have been better?
Could do some improvement.
Yeah, because by the time the IT student, well, all of you actually, by the time you get to your final year, you will have, as part of one of your modules, enterprise systems and or information security insurance, you will actually have to create a poster that you will put up there, and I shan't mark them. I shall own the marking and have oversight of it, but you will mark each other's posters for 30% or so of the grade. And so again, it's all to do with learning to communicate really effectively, because posters are there to communicate ideas. And one of the biggest problems in the world of big data analytics, as comes out in various conferences I've been to over the last year and a half, is that people who are good at doing analytics tend not to be able to tell the story terribly well. And one of the things about analytics is being able to turn those graphs, those amazingly dry-looking tables of numbers and statistics and correlation coefficients and t-tests and who knows what, turning those into the story that is convincing to the decision makers, that helps them to understand what's actually happening behind all of that data. in ways that connect with the decisions that they have got to do. In other words, we're not wanting you to develop as geeks who are brilliant at analytics but can't communicate. Who can't communicate in the language of the actual audience. And one of the best examples I know of how not to do it was an advert that I think it was Microsoft had on TV some years ago, where they were trying to sell the idea, well, they were selling Microsoft, the provider of solutions. And it's about their Active Directory. Don't know if you remember that one, do you, Ian? Anyway, there were two guys standing in this big open office. A little guy, sort of the classic IT geek. And there's this big, bluff guy who was about 6'3" tall, about that broad, and he was the senior manager. And the geeky guy was saying, hey, we had a fantastic implementation over the weekend. We implemented LDAP and we implemented all these geeky 4-letter and 3-letter acronyms. And the senior manager was getting very, very bored. Yeah, I know he'd sponsored the project and it would cost about $500,000 or something. But he didn't want to know the fact that they'd done it on time particularly. He wasn't very worried about that because that was going to happen anyway, wasn't it? And yes, they'd managed to consolidate 50 or 100 directories across their server estate landscape, and they'd consolidated tens or hundreds of thousands of directory entries. And you could see this manager getting ready to go boom on this really irritating geek who was not communicating in language that he was interested in. And suddenly the little guy said, oh, and by the way, we saved $500,000 on what it would have cost us to run these disparate directories if we'd stayed on with this project without this project. And we've now saved ourselves operational cost of $500,000 a year. And suddenly, oh, that's my language, guys. I understand that sort of saving. Why didn't you tell me that at the very beginning of the discussion? Why did I need to know about how many hundreds or thousands of servers and directories and? I'm not interested. Just want to know the business answer. And what you will be wanting to learn over the next 3 years, as we teach you analytics and SAS and so on, is thinking about who is the stakeholder who is most interested in the work you are doing. And as we look at the sorts of data that, and we'll see a few slides in a little while, about how to find sources of information, where lots of interesting sources are, the first thing you are going to need to think about as you download one of these sets of data for your project is who is interested in this information? Who will be interested in getting answers from this morass of data? And then when you've asked the question who, and in fact to yourself answered it, you'll then start thinking about the sort of aspects like, well, if that is the type of stakeholder, it might be a chief executive of an organisation, or it might be doctors, if you're looking at medical data, or it might be medical researchers who are trying to crawl through all of the epidemiological data, say, about Ebola in Southwest Africa, or in Northwest Africa, where they've been having it for the last few months. Now, what are the questions that these guys need to understand so that we can prepare more effectively to deal with the next outbreak, maybe of Ebola or something else that's really nasty that we've never seen before or that we have no defences against? So we want to try and think about what sort of questions will that stakeholder want to get answers for out of that set of data. So who is the stakeholder? What sort of questions, what sort of answers? And then you have to start thinking about, okay, and what sort of language? What sort of words are are they familiar with as I develop my story? So those are the sort of things that you will need to be thinking about all the way through this module and then through into next year and the year after. Thinking about your communication skills. How do you connect with your audience? What is it that makes them listen to you very, very carefully? And so having little exercises like you're going to have as presenting is going to help you to develop those skills, and we'll help you with feedback. So that, you know, because we've got different backgrounds here, and so you'll be communicating to me, you'll be communicating to other academics, you'll be communicating to each other, and all of you have got different backgrounds, different experiences. And you guys from the Joint Honours Programme are kind of interesting because you've got very, very different backgrounds. Accounting, education. What else? Who's the third one?
Psychology.
And psychology. Oh, sorry, I keep forgetting. Yeah, psychology. So, you know, 3 incredibly different areas, and actually 3 incredibly important areas of the big wide world that we're actually applying big data analytics to. So, don't know why that's come up, but hey, one random thing of Windows, I guess.
Got too close to the board again, I think.
Ah, of course I got, yeah, right, now.
Richard Arch.
Really must feed back into the system. I'm part of the working party that looks after this refurbishment, and I keep forgetting, well, we haven't had a meeting yet, but this irritating touch sensitivity is kind of interesting.
This future of technology is so annoying.
The future of technology is so annoying. I wonder how we record that in a way that's useful and we can communicate to people out there that can they slow down the march of technology so we don't actually... Hey, who heard about these lovely Samsung TVs yesterday?
More specific?
Pardon?
Be more specific?
Ah, you haven't read the article or heard the article.
So,
Oh!
a few things about Samsung TV.
This is Samsung and others are now producing these magical new super smart TVs with voice recognition. So you just have to say, hey TV or something.
It collects all your data.
Yeah,
Well-
listening on users' personal conversations.
It listens in, and the problem is this voice recognition doesn't work in the TV. It's funneled off the internet to some company who does voice recognition that processes it and then shunts it back to your TV to say, oh, change to the menu or whatever, or channel something or other. But whilst that microphone is on for your voice control of your TV, it's also recording everything else that's going on in. So, you know, if you happen to be having conversations that you really wouldn't want the world to know about, that's still being funneled off down there. You know, credit card details or password, yeah, it's all there. Yeah. Or another one that one of my final year students has discovered about the Internet of Things is that in the States, the traffic control, all of the traffic light controllers chatter over Wi-Fi. They don't have a wire between the individual traffic lights, which is nice and sort of comparatively secure. It's all Wi-Fi. Who saw or has seen Die Hard 4? Yeah. Everything in that is actually capable of happening now. There are people who have already broken into these Wi-Fi traffic control systems in the States. And hey, we've been doing it actually in film since the Italian Job revisited, haven't we? In fact, the original Italian Job had control of the traffic lights, didn't it? So, we have to be careful. We need to communicate to the right people. So, what I want to do is just get started on today's little... Oh, no, I've got to minimise that and... Do I want it to remember my credentials? Probably not. So, as we start moving into our expertise with SAS, yeah, in the SAS chapters from about chapter 2 or 3 onwards, you know, they give you all of the data in the Orion data set for you. But that's not going to be very useful for the little projects that you are going to complete. So this little section, and then who hasn't got an electronic gadget, otherwise known as a laptop, handy in the groups? Group there, you two have got one, you've got one there, you've not got one yet.
I've got it at home, it's on charge, so I'm not brought it today. The first week we're not bringing it.
Okay, right. Do you guys, between you, have a laptop you can bring in for next week? Okay, make sure everybody's got a laptop per pair for next week, because that's going to make life a lot easier, because you know, I don't really want to spend all 2 hours just kind of doing desk type of activity or standing here and talking at you all the time, because you're going to get bored eventually. So let's have a look at a little way. You talked a bit about, or hopefully quite a reasonable amount, about ETL last week. Let's go back one further stage, finding that information. Where to start, and that's kind of where can I get data from, but having found a chunk of data, the first thing is to actually explore it. I don't care whether you explore it in Excel or whether you just suck it into SAS and do some fun things with it, or what, but you need to explore the data. Find out what's in there. Maybe use a prop contents to find out what the variables, fields, names are. If it's coming in from SAS, if it's coming in from Excel, well, look at the column headings to try and understand what's there. If there's a tab on this spreadsheet, perhaps it might tell you all sorts of interesting things about how the data's structured, what some of it means. And then actually look at the data values. You might want to do a prop freak or something like that to find out what the categories are and how many instances of each category there are for a particular variable or column. It's always kind of interesting because you can find some interesting things. There's 1 or 2 in that list of values which don't fit in terribly well, perhaps. That helps you to find out, has someone been playing with the system and bending it because there's something that needs to be recorded by the business, but the system wasn't designed to collect that, but the job requires it, so they create special values. Special names that are, this is how I've fixed the system, to capture, to record at least the data I need to have recorded about the task I've just completed. And whenever I did this sort of work in SAS at Rolls-Royce back in the mid-late 80s, early 90s, every legacy system I looked at to do some work for customers, i.e. other people in the office who wanted data analysed or fixed, it was, well, what does that particular term mean? It's not part of the standard that was in the specification, the original specification, but you've got something new. And then there's always Richard, yes. That was because the system was designed not to do that, but we needed to do that. And so this thing, which is about that type of thing, but it's about, I wanted to record this, has a special value. 99999, maybe. And then they would develop, having done the 99999 special version, there's a 99998, which is a slightly different variation of the 99999 one. And you've got to do some very special logic to capture those 99998s and 99999 records and shunt them over there to keep them out of the way of all the rest, which is about something else completely entirely different. Come across that one, Ian?
Yeah, kind of thing, yeah.
Regularly. So you explore the data to find out what's there. Often in the analytics world, today we assume we've got fairly clean-ish sort of data going into our systems. You still need to explore the data to find out what is there, find out what sort of questions you might be able to ask. So here are a set, just nice and simple. We'll have a look at WHO. And here's the website where you can get amazing amounts of data. Just explore it, have a look at the data tab, for example. Oh, look, here is a data repository. I wonder what's there, folks. You've got statistics, you've even got a gallery of maps where they've processed it already into a graphic-y sort of style. Oh, what a marvellous range of information, huge amounts there. Whether it's to do with urban, neglected tropical diseases, yeah, everything, or a whole range of things here that you could download. They could be one of your sources, if you wanted to have it, for a project, if you were interested in medical sorts of information. Or the Guardian. Basically, just go down until you find something interesting in here. The Guardian actually is an area that you need to spend a little time playing and following your nose, and maybe it's gone the wrong place and come back a bit, and you'll eventually get to some really interesting sets of numbers. Amazon. Public data sets. You might have to do a little bit of registration to download it, but out of here, you can, if you're careful, you can extract some fairly large and very, very interesting data sets. Hmm? Do they?
No, they should charge that, I'm saying.
Well, there are two sorts of data out there. There's proprietary data, which people want to keep for themselves because it's company confidential, it's related to my profitability. But there are a huge number of sets of data which are collected by governments in general terms, or government organisations, which then become publicly available, or made publicly available because they're of interest to lots of people. For example, in the UK, every single city council or county council is required to publish monthly a list of all of their expenses over or £500 and above. If you go to Derbyshire County Council, you can get a single spreadsheet, single tab even, it's a nice spreadsheet, which is about several thousand rows long or deep, which has everything that goes through their accounting system that's more than 500 quid. Categorised by account codes, names, although sometimes, or the payee, although they're a bit careful to make sure that they can't be individual people can be identified. So if it's maybe a payment to somebody for home services, they won't identify who the recipient was. But if it's an organisation, they'll mention it. So anonymity of individuals is always preserved, of organisations as a general rule not. And that's there so that people like us can go download all of the data, pour it through something like SAS or SPSS or R, and find some interesting facts about how our county council or our city council spends its money on what and how much and what proportion of the budget is spent on this, so that we can keep an eye on what the councillors are actually doing, called sort of transparency. And there's huge amounts of data goes into these big public data sets. A lot of work that's research work done by academics ends up on these data sets, whether it's geology or oceanography, or the medical stuff, the disease research. A lot of it becomes publicly available. So there's a lot of stuff there you can have a look at.
On the Amazon one, you ought to check the sizes though, because I bet a lot of those data sets are very, very big.
They might well be.
Downloading them, you might,
Yeah.
and you
Yeah.
think
No, if it's I mean here it doesn't really matter. If you download the gigabyte, it'll only take you a few minutes because we've got a 2 gigabit line into the university now. The server at the other end won't serve it at that speed, so it might take you a few minutes to download a gig. But be careful. By the way, if you've got a data set of a gig, it's going to be a bit problematic getting it into your virtual machine on your laptop because it's constrained at a certain volume. I don't know how big a data set the Analytics U SAS system will take, but it's fairly heavily throttled, whereas the PC version can cope with pretty much anything. It might take a little while, but it'll still process it. You've got the US government here, for example. Nope. And you can sort of explore here. Some of that does lead eventually to some interesting data. Some you may have to explore a little bit hard at times to find some interesting sizes of data sets, but there's a lot of stuff here. And this one, the Office of National Statistics for the UK, provides unbelievable amounts of data coming out of government, all sorts of stuff. Whether it's business, health, mortality data, and it just goes on and on and on. And this might be a very interesting area to find something maybe for businessy sort of stuff or whatever. Explore. So, exploring the data. You've downloaded maybe a big fat CSV file or an Excel spreadsheet. So what you'll then do, and you're covering some of it over the next few weeks with your formal stuff, but we can teach you in class how to use InFile and also how to use the import wizard, which is kind of neat to use. In fact, the import wizard is much better most of the time, unless you want to really control it heavily. So you just suck the data out of a spreadsheet, out of a CSV file, into SAS, and then do something. And basically, you'll find SAS has got all the procedures you could possibly imagine that you want to use to explore that data. Whether you want to do it as tables or sets of numbers, or whether you want to pour it into one of the graphics products. And you've also got the opportunity either to use the old PROC-G, plot, G bar and so on, or to use the S plots, which are the new, more modern ones, which are much higher resolution, much better quality graphics. So the SG plot does pretty much everything you want. You just switch on the ODS system, find the manual for ODS on output display systems, and work your way through that and track down how to make it work. And if you want to make images that you can put into your reports, you even have the opportunity or ability in ODS to create PNG files, i.e. JPEG files, which you can then just embed into your Word documents nice and simply. Think about sequencing by groups. Use proc sort to sort in different sequences, and then do some of these proc statistics here. or you leave it in Excel and do some fun stuff there, if you know how to use Excel. I mean, sometimes it's actually worthwhile, if you download a CSV or an Excel spreadsheet from somewhere, having a quick inspect, just look at it, scroll up and down the data, maybe select one or two of the columns and turn them into a wavy line using a graph or something, or pour it into SAS and do all the work there. It doesn't matter what works. I would encourage you ultimately to end up doing most of your work in SAS, because hey, it's an awful lot more powerful and capable of handling vastly more data than Excel can do in any sensible sort of manner. Now, one of the things that this reminds me about is how, as you start building some of this SAS code that you're going to be using as you explore your data, is to save. Yes, you might want to edit it in the little program editor window, but as you start developing it, remember to save that into a file, a SAS file, somewhere. Keep it nicely structured so that you don't forget things. And one of the things that I greatly regret is that I didn't manage to keep any of my SAS code from when I was at Rolls-Royce. I had some spectacularly amazing code that would have been really, really useful. And in fact, I lost it in around about 1985 because I didn't access it regularly enough. And by the time I wanted to reuse it in about 1997 or 8, it kind of evaporated. But there's some stuff there that was really quite magical. That someone else had written parts of it, and then I'd developed further from it. One of these days I've got to recreate a lot of it because I need to recreate it. I've got a real purpose, guys, now, so I'm going to start learning SAS because I've got a purpose to it. A lot of research I'm doing, number crunching, lots of numbers, displaying them in all sorts of different ways, and you build up a library of chunks of code that does specific things. And that's where this comment that comes from. As you're developing it, sometimes you just want to get rid of that. You don't want to process that chunk of code, but you want to process the stuff in front and stuff behind. Don't delete it and save it, because then you've lost your knowledge. Just comment it out, because you can always uncomment it and reprocess it, those steps. So think about how you build that set of processes you're going to work on, whether it's the import side, and if you're going to use in file, well, one of the simplest ways with a good piece of spreadsheet which got nice column titles is actually to use the import wizard and tell the import wizard to actually create the proc in file type of code for you, so that you can then edit that and have more control over maybe the labels of the variables, the variable names, because sometimes it'll just give you var 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, one after the other if there's no sensible headings. And that's not actually terribly useful in the long run. You need to have meaningful names. And so build that library of functions, libraries of chunks of code which you can then bring together for your demonstration for me at the end of term, or to keep safely for when you want to do some more SAS work next year and so on. But there's going to be a gap of a few months between the end of this term and when you next start using SAS. And so to have your knowledge captured as chunks of SAS code is going to be really valuable. And remember to put comments in your code. This section does this like this. Don't assume that you're going to be able to remember why a year ago you wrote that chunk of code like that. Because you won't. Lots of comments. Make it, and if you choose the variable names so that they mean something, so put lots of underscores in instead of spaces between the names, so you can read the title of the variable within the limitations of how long you can use. That's kind of, again, very helpful. Yeah, I know you have to type a bit more as you develop the code, but it's much easier to type it accurately if it's the words, it's sort of natural English. And I did this with a language called APL, it's an IBM Curiosity from 30 years ago. And it's kind of a symbolic processing matrix kind of manipulating thing, but it can work on pretty much anything. But it didn't mind how long the names of variables were, it didn't mind how long the names of functions were, or anything, so you could actually end up writing almost natural language, within some constraints. And it meant it was self-documenting, and it was easy to understand 3-4 years later if you needed to. It's like spreadsheets. How often have you developed a really fun big spreadsheet, sort of several tabs worth, many layers with hundreds of columns and rows, and then put it away because it's done what I want to do, and then a little while later you come back to it and say, I'd like to improve it or to expand it by this or that. If it's more than 6 months ago that you wrote that spreadsheet, I bet it's probably quicker to rewrite the new improved one from scratch than to spend time trying to understand what it was that you did, why it worked, how it worked. And this is really important in business because if you're good at spreadsheets, you will be the departmental spreadsheet creator. And then the boss is going to say, hey, you remember, Richard, that spreadsheet you did last year about this? Yeah, well, I'd like you to modify it a bit. It's not quite this, what you did then, but it's now, we need to modify it a little bit more to do this and that and that. And it's, yeah. I don't remember how it worked. I don't know how the links between this layer and that layer work particularly well, and you want me to put another layer in between there. Right. And with your SAS code, there's going to be a danger. If you're not careful, if you haven't commented it correctly or carefully, you'll think, yeah, it says that. Wonder why? What was that related to? What's that bit of special processing there that says if variable x greater than or equal to 60, then variable y, or y, equals g. And if it's not, then it's no. What does n and g mean? And why was that magical 60 there? Document it, document it, document it. And you'll find on our, if you go on our, all of our computing, specialist computers, you can also use another little nifty gadget related to SAS called JMP or JUMP. And you could explore that if you wanted to. It's kind of sort of a cross between a spreadsheet and SAS in broad sense. So you could explore that because that's another really important product that's used out there by the SAS community at the small level. So you might want to explore that at some stage. So, comes back a little bit to what I was saying earlier on, doesn't it? About, what are the questions about the data? Who are the stakeholders who might be my audience? Let me just sit forward a minute. Ah, there we are, yeah. Here is a little activity for those who have devices. So if I suggest you move around a little bit so you're in groups of, I guess, probably 4, so that then probably gives you at least, well, either 2 or 4. So at least you've all got access. You can see a laptop or something that's working. Find the data set. Well, you haven't got the ability now, but you can do in the workshop on the next workshop, do some of it. Do it in Excel first of all, to explore the data. Just get a data set. Now, let me see if I can find a fun one. No, you go find a data set, a smallish data set on the net, which downloads as an XLS file. So the ONS ones are probably a good one, good place to go, because a lot of those are Excel spreadsheets in there. So go to there, find a spreadsheet, just to sort of look through there, perhaps search for something, download it, and then explore the data in Excel to find some interesting questions in that data. Okay?